This section, what we're doing for project 2 is the Apache server. And a lot of this is not covered in our textbook. So that's what I call it. We're doing a little bit of chapter 15, the concepts of networking, and then the value added client server and LAMP stack. We're actually going to install the Apache web server, and we're going to create a simple HTML web page. All domain names, whether it's bergen.edu, it has a computer part and then a network part. So the .edu is the network part. All of those have to be converted into a unique IP address. Every computer that's on the internet has a unique IP address. Just like if the post office was delivering the mail, each of you have a unique address. So the purpose is to translate host names into IP address. The host names are the user-friendly names, right? If you had to memorize the IP address for bergen.edu, it's not really a very friendly name to remember. It's numbers. And then there's something called the dynamic host configuration protocol. If your computer is a server and it's acting as a server, then you're going to want it to have a fixed IP address, a static IP address. However, the clients that you serve, you can use the dynamic host configuration protocol to generate an IP address for them to use. So when you hire a service provider, like in my case, I don't know, I have a service provider, and when I connect to the internet, they lease me an IP address. It's not permanent for my computer. When I'm done and I log out, somebody else might use that same IP address. So they might have, 500 IP addresses and they get cycled through. Now, the internet is a global network of interconnected computers that all use TCPIP to communicate. Right? If we had a global network and you were going on Zoom to talk with people from other areas of the country, if you each speak a different language, it's kind of difficult to communicate. So the TCP/IP language, the protocol, is common to all internet computers. That is the language each computer talks. And right now we have a 4-part dotted IP address. And next it's going to go to 6 and then 8. We're running out of IP addresses, with devices requiring addresses. Soon we'll have an 8-part. There's also something called media access control. This is how the computers communicate to the wire or wireless. So there's something called CSMA-CD, carrier sense. That means that the computers are listening on the network if somebody else is sending. Multiple access means that your computer, as well as some other computer, can write to the network at the same time. Collision detection is what happens if you write exactly at the same time. Well, one is going to back off, ran some sort of algorithm. One backs off and then the other one tries again. And then there's also something that I was always fascinated with. It's called IBM token ring. This is going back to the IBM days, but it really makes the concept easy to understand. How many of you deal with small children, nieces, nephews, kids, grandkids? Sometimes the kids, when they're small, they get all excited and they want to share what happened. And, they have a lot of energy. And instead of noticing that the sister or brother is talking at the same time, they try to outdo each other by talking louder. They don't care that the other person's talking. They figure the person who's loudest, when my kids were little, I always thought, wouldn't it be great if I could teach my kids this IBM token ring? And the way it works is, imagine a large meeting room with people, and you have a microphone. So whoever has the microphone will talk and then pass it to the next person. So you can only speak when the person is holding the token. Ping. This is the command that sends out a packet and waits for it to return. When I worked for Digital Equipment Corporation, at the time, the Unix systems did not come, they didn't all come with TCPIP installed. So part of my job was to make sure to install it and then to test that it worked. And the first thing we would do to test that it was working was we would ping ourselves, because that just isolates the fact that TCPIP is working if I can ping myself. Then if I want, I can ping some other computer, but then there's variables like the servers and routers that we have to test. This keyword, localhost, refers to your IP address, your computer IP address. It's a term that's often used. Ping is the command, and it's an acronym. It's for Packet Internet Groper. If you don't put this -C2, it will just continuously ping until you hit Control-C to cancel it. So the -C is the count option. So I'm going to do -C3. I only wanted to send the packet 3 times, and localhost refers to send it to myself. Okay, so it sends out this 64-byte packet, and it shows at the bottom 3 packets transmitted, 3 received, no packet loss, and it gives you a time. How does the domain name server, DNS, how does that translate the domain name into an IP address?
Doesn't it look up like a call sign of some kind in like the basically the internet registry, and then it finds it from there, and then it'll redirect you to that?
Right. Well, the Internet Assigned Numbers Association, the registry, what happens is the tree structure here is similar to the Unix file system, where you have a single root server. And then you have 13 what we call top level domains. And it used to be that the 13 were .org, which at the time when it was first developed it had to be a nonprofit organization. .com had to be a commercial organization. .mil is military. .net, .gov and .mil are like the 2 that are strict. They have to be military and government. So for example, if you went to whitehouse.net, that's not the White House site. It's whitehouse.gov is the official site. The top level servers, all they do is translate the last part. Think about it this way. Let me see if I could. Okay, so here's maris.edu. A domain name will have 3 parts. The maris.edu is the domain name. .edu is the first part that gets diagnosed or found. So when we want to go from where we are, our computer on a Bergen network, for example, and we want to go to mail.maris.edu, the first part is we have to find the .edu server. Okay, so this .edu server here is going to locate any .edu domain name and translate the IP address of their server. So if I was, let's say, going to, let's just use something that's in here, WPU, because that's in here. Okay. So if we're at the Bergen network and we want to go to WPU, mail.wpu.edu, for example, we have to go up to the edu server to find out the address of the WPU machine, their IP address. So then it takes us down to this computer, and this computer will locate the mail server. This first part is which computer in their network. Just like on Bergen, we used to have mail.bergen.edu, and then we have view.bergen.edu. We have several different server names. Okay, so now if you're at Bergen and you want to go to WPU, it's just really, you go up to here and then you go down. But if you wanted to go to whitehouse.gov, well, EDU's not going to know where whitehouse.gov is. So it's going to relay your message to the very top level domain, the one that has the 13 top level domains, and it's going to find the .gov server. It directs your request to this .gov server here, and the .gov server will find the one that you're looking for. If it's whitehouse.gov, it's going to take you there. And then that computer will take you to, if there's a subpage. If we want to know our IP address, this command will tell us. So host name dash I. Okay, there's your IP address. And now, if you did this host command on bergen.edu, see if it works. Okay. It tells you if they're, in our case, our mail.bergen.edu is farmed out to Google because we use Gmail. So it's not a computer on our network, it's Gmail. Also, if you go to moodle.bergen.edu, that's also not a Bergen computer. It's an alias to this dlbergenmrooms.net. A client is a software, or sometimes hardware and software, that sends a request to the server. Like your browser is a client, it might send a request to whitehouse.gov. Whitehouse.gov is the server for their White House pages. The server responds to that request. A daemon process is usually what's running on the server. There's a process continually running in the background on the server, awaiting request to connect. And what we're focused on is LAMP. But if you have a MacBook, there's XAMPP, because a MacBook has OS X as its Unix derivative operating system. So I still have OS X. And when I applied for the job here at Bergen as an instructional designer, there was one thing on the application that I really wasn't that familiar with, and that was Moodle, which is a big part of what I do, is helping faculty.
Makes sense.
So luckily, because Moodle's open source and because I have OS X and I can load the server, and it used to make me nervous because I'm always afraid that when I run the server, I am a target for hackers. The way it works with Moodle is it uses SQL. These are some terms you need to know. Okay, I'm going to ask, who knows, when was the internet started? And what is the difference between the internet and the World Wide Web? Yeah, the early 70s is when the internet started. I don't remember the exact year, but I know that I was at AT&T by 1980. I was using it at the dollar prompt. We would type Usenet, and that would put us into a black and white screen. They were discussion boards. Hypertext transfer, the web is the graphical portion, and the key is that in the early 90s, that's when the browsers were developed, Netscape, Firefox. So that gave a whole new way of searching. Do hostname-I, right? Okay, that'll give you your hostname IP address. And I want you to take that number and type it into your browser. Okay, so whatever it is, 148.100.78.1 or whatever it is. Okay, I'm getting an error. How many of you are getting this same exact error? Okay. And the reason why we're getting this error is because we don't have Apache running. We can't act as a web server unless we install Apache. All right, so we're going to do some of these steps together. Now, usually I don't like the idea of becoming root. In this sudo command, we're actually becoming root. But there's a few commands we have to do as root. So you're going to do sudo su dash. We're going to become root. And the only indicator is this pound symbol that we're root. And you're going to type this apt install Apache 2. When you run it, it will prompt you, it will tell you how much space it's going to take, and you have to say yes to continue. Okay, so now the next step, now that it's installed, is this command. systemctl, one word, start Apache 2. So once you have this command, this systemctl start Apache 2, your server is up and running, and then you want to copy your IP address here, and you want to put that into a browser. Okay, you should get something that looks like this. And basically in red, it says it works. Okay. I'll make that part.
Yep, I got that.
Okay. And there's some documentation and links that you could look at. So now we're going to go into the directory that's the default home for your pages. So cd/var/www/html and hit return. Now you should only have one file in here, and that is index.html. Do you want to make a copy of that? So you'll copy index.html to index2.html. Well, for what we're going to do, it's good practice on your VI skills. This is what we did. We used a browser. And what we're going to do is HTML, we're going to create a title of the page, which goes on top of the tab. So just a little bit. Here's some very basic code. HTML, they're interpreted by the browser, and the tags will have an open and a close. The close tag will have this / before the name of the tag. And these tags are nested within each other. All right, so the first tag is HTML and the last tag is /HTML. For now, what I recommend we do is vi eg1.html. We'll create a new file, and we're going to put these tags in it. There's a header section, and that's where you put the title of the page. So that gets nested within the header tags or the head tag. And then there's a body section where the text of your page will go. Okay. And this H1 is header level 1, and P is just a paragraph tag. And at the end is you close off the body and you close off HTML. So once you have entered this here and saved it, we can go back to our browser, and then we add a slash and the name of the file, pg1.html. And then you will see this. You'll see the title of your page here in the header, right at the top here. Okay, so that's the title of the page. And this is your header level 1. Comes out very big. Now, when you want to create your web page, you don't want it to read like a book. You want to take advantage of white space. You don't want it to be too cluttered. But first, let's make some changes to it. Header level 1 is going to be the largest text. It's the topmost header. But there's several different levels. What would happen if you changed this H1 to H2? And what you would want to do that is move your cursor, use W to get to the beginning of the word. The R command will replace the character under it. So we hit R and 2. Okay. And then the same thing would have to happen to this one. R, replace with 2, escape, and then W. And now we can go back to our browser. Okay, so notice now the header is smaller. It's a second level header. In this document, for example, lists are very important, and the UL is an unordered list tag. You start and you end with it, and then LI is for each list item. And that's a very good way to create content. So I'm going to open a new line. P is the paragraph tag, and what I'm going to want you to do is what I learned or was challenged by in this activity. So I want you to share with me what concepts you were able to understand. If you were confused about something, you can share it, and you can put it as a sentence format, or you can have an ordered list, OL. And the way that works is LI is for each item by, and then a third one, LI. And then I close off the ordered list tag. Hit escape, Q. So now if I reload this, now I see my text. So that's you're going to fill in. What did you get out of this lab? This is your reflection. Okay, so at this point, you basically completed the project. Okay, if you got this far, the only thing you have to do though is you have to add your name to the page. So what I recommend is in header 2, and then put it here. So you put your name in there. Now the only thing is right now we have to add this page1.htm, but we can put this in index.html and then we don't have to add that because index.html is the default homepage. What I want you to do is clobber your index.html, the original. You're going to clobber it with the greater than. And now you're going to go into vi index.html. Who remembers the command in VI that will read in the contents of another file? What we want to do is read in, and I'll give you a hint. The first letter of read is, all right, so then all you need to do is colon, so go down to the bottom, escape colon, and then rpg1.html, and whatever was in there will get read in. And then colon W, we'll save it. WQ to exit.
Oh, it's using that one. Okay.
All right, so if I show you this, it should look familiar. What did we do? We did apt install. We did hostname, we plugged it in. We did copied our index file. We put our code. We tested what happens if we change mode to 640 and we take away rights from other. You're going to have a problem if you do that, because you need other to have read access. So you can play around with that just to see what happens on your own.
And then we have to answer all these questions too, right?
Well, just the question in number 15. You're answering what you learned from this lab. That's it. And then you're just going to submit to me your IP address. And if all this is in your index.html, then I'll find it and grade you. So your 4-part IP address is what you'll submit.
Okay.
All right?
And then it's just like what I learned or what I was challenged by in an ordered or unordered list.
If you don't feel comfortable with an ordered list, then that's optional. I think it would look nicer, but you could also just write it as a paragraph.
Okay. So
I'll leave that up to you. I just want you to be familiar with some of the tags, because when we get to the PHP lab, we're going to have a combination of HTML and PHP. So
I think I might have messed up on something, because when I put down in terminal what I needed to do, I tried saving it and I think I made a mistake. I didn't specify a file name of where to save it to. So as a result, it can't set. Now it's saying whenever I'm trying to save it says can't open file for writing. I think I might have messed up somewhere.
well, maybe you exited out of root access. In other words, you have to be super user to write in that.
Dang it. Great, I'm going to lose the work I just did and I can't even exit, because when I try to exit, it says, you cannot save.
Well, you could always copy and paste it into a text file.
Alrighty. Control Shift C. Okay, how do I exit here? Okay, I did this and WQ exclamation mark, and it won't let me leave.
Yeah, you'll have to do Q exclamation, colon Q exclamation.
There we go. Now I'm out. Now then, let's do SUD. I'm gonna put SU. What's the password for sudo on this on the server?
Type sudo space SU space dash. That's it, because we don't use passwords on this server. We use the keys.